And if you are asked to describe the global patterns, note how to go by them. The locations, the Pacific Ring of Fire that we dealt with, the Aegean through the Mediterranean, then the mid-Atlantic Ocean. That is how we have to go by them. Don't forget that the distribution of these plates are governed by convective currents. The processes have already been done, but if you're asked to describe or explain how the processes can lead to the formation of the landforms, note that the sea floor spreading is one of them. You'll be asked to define the term sea floor spreading. The sea floor spreading, that is the moving apart of the ocean plate boundaries. One mark is given you as a result of convective currents. One mark is given you. So don't forget the role of convective currents and then the moving apart rate. The ocean ridges. The ridges are a form of mountains that are created from the opening of the oceanic place with the upwelling of magma solidifying to form the ridge. So that one too, the spreading apart of ocean plates. So that's what we have done. The mid-Atlantic ridge we dealt with is caused from the spreading of the mid-oceans driven by convective currents, 1 month. When it cools, it solidifies to give us the ridge. So, you have to give us 3 points to get the 3 marks. Is that okay? Get the 3 points to give us the 3 marks. Ocean ridges, first of all, from the widening of the spreading of the ocean as a result of convective currents, and then they hardening to become the ridge. No, it's just a form of tectonic landform to show that. And this can form the ridge. This is a type of the ridge that they are dealing with. Okay? These are the form of the ridge that we are dealing with. The ocean trenches. Put down your short notes on this. The question is, describe and explain the formation of ocean trenches. Describe and explain. This is a dual command. Describe and explain. We need to meet these 2 demands. It's a dual command. So if you are describing, tell us the features of that landform. And then go further to give me why it has been formed or how it has been formed. So the question is, both description and explanation need to be present. You need to use the explanation and the description to get the full mark. How are they formed? The ocean trenches. I told you that they are formed from the subduction of the 2 oceanic plates. And then the downwarping of the plates will lead to the crushing of some of these materials, leading to the trench forming, this narrow, deep depression forming from the subducted plates. Accretion. Accretional words, that's strapping, strapping of the sediments from the seabed, strapping of the sediment from the seabed. Yes. The scrapping of the sediments for the what? The ocean trench, the submerged plates will create that deep depression, yes, under the ocean bed to create the trenches, the down warping. So ocean trenches, they are narrow, deep depressions that are formed under the bed of the oceans. Trench. I said that the spread centers give us ridges. Okay, the spreading centers, sea floor spreading, the ocean floor is opening and the magma is coming up. The magma will get solidified and create the ridge. The trenches are depressions that are formed from the subduction of the oceanic plates. Have you got a difference? Hmm. The volcanic arcs. I told that the arcs are also formed from the subduction of the two oceanic plates. In this case, one of the oceanic plates, they melt. Okay, the melting of these plates will give us magma, and it comes up as volcanoes. So it forms different volcanic islands around it. So island arcs are formed along a convergent plate boundary where there is a subduction zone between two oceanic plates. Don't forget the movement being triggered by convective current. We mark them. The denser oceanic plate is subducted below the other oceanic plate. We mark. And they occur in a curved linear chains. That chains of volcanoes that are formed from that. That one I don't know now. I don't know now why they are curved. So go and search. They come and tell me. The descending plate through the process of subduction is melted. It's okay. So you need to hammer on the melting effect of the subducted one, giving us magma to create the volcanoes on the surface. It's a chain. It's a chain of volcanoes, different islands. Okay, the island arcs. So the difference between volcanic arcs and ocean trenches, we are doing all these landforms. We are going to get a question on this. Simple questions like that. So take notes. Don't confuse that with mid-Atlantic ridges. The ridges are around the what? The spreading centers, where magma is coming up, solidifying to give us elongated hills or mountains at the floor of the oceans. Okay? The ridge is a mount, it's like a mountain. I told that for the ridge, there's no subduction occurring. How can subduction occur at the spreading centers? When it's pressed, I said when it's pressed, magma comes up from that center. It's okay. It solidifies to give us a mound type of a ridge. But at the subduction zone, it's going to create depression because of the effect, the downwarping of the oceanic plate. Okay, creating that depression there. The island arcs, there should be the melting of the plates. under one oceanic plate. Yes, it melts. There's a better one melts. Yes, opening they come out to give us, yes, to give us curvilinear form of volcanoes, to give us volcanic island arcs. But most of the islands are oceanic islands. Most of the islands, okay, volcanic islands under the sea. Describe the process of fold mountain building. How do fold mountains get formed? The concept behind the formation of fold mountains, you need to link them to the plate margins, at the convergent plate margins and at the coalition plate margins. And in all these two areas, the way in which they are formed differs. Fold mountains are created when oceanic plates are subducted under continental plates and when two continental plates collide. So these two concepts or these two scenarios, you should be able to know where they are occurring. It's okay. The oceanic plate, the Nazca, South America, giving us the Andes fold mountains. That's the case study. The Indo-Australian and the what? Euro-Asia meeting to give us, these two continental plates are meeting to give us what? Himalayas fold mountain, because they thrust up. The types of plates and tectonic landforms. That one you have already done that. The convergent plate margins, divergent, conservative, you need to note it. And find out the type of landforms that are created at these areas. The destructive boundaries lead to the formation of volcanoes, ocean trenches, and fold mountains. Divergent boundaries lead to volcanoes, but not fold what? Mountains. You can't find fold mountains at divergent plate boundaries, but you can have the mid ridges. Conservative margins, you cannot find volcanoes and you can't find fold mountains, but there are earthquakes at that point. Okay, these are the specific distinctions that we need to take into consideration. Describe the processes and explain the landforms produced at divergent plate margins. We have done it on the board. Okay, when the plates diverge, we get what landforms? Ocean ridges and what? The fault valleys, the rift valleys in the continental interior of the plates. In all cases, don't forget the role played by the convective currents. They are very important. Now, the creation of the mid-ocean trench or the rift valleys, the upwelling of basalt. Upwelling of basalt. Basalts are a form of igneous rock. Okay, they are all formed from magma solidification. Transform faults, that is the formation of the rift valleys. Check all these. The diagram is needed to support your work. When a work like this is given you, please sharpen your pencils, take your erasers, and then draw to support. Look at this question. Convection currents are the most significant factor in the formation of landforms at divergent plate boundaries. Have you seen the nature of question they ask? In all cases, they draw either a process out of it or one factor. And you have to explain that point given, and then we draw other factors that work together to give the landform. Are you okay? So convection currents, much as is very important in the movement of the plates, we cannot do without them. But it is not only the converting currents that forms the landform at the plate margins. Is okay? Are you here? So these are some of the landforms that we can have at the divergent margins. It's a lava. You know lava? Magma, when magma comes out of the timber and it mixes with the it's now a lava. Icelandic. Yes, the Iceland is at the mid-Atlantic ridge. Is that okay? Yes, yes. So check how the question has to be answered. The approach could be comparing the conversion currents, that is the one in the question, are the most significant, and then compare this with other factors. The question says convective currents. When that question is given, you exhaust this point, but because it's an evaluative question, consider other factors that also help in that formation. The forces of extensional force. These are the tensional forces. The type of magma that comes out. Basalt, okay? Basaltic lava, those things. And then the actual location. That's the specific margin that we are using to support that. So convective currents are important. So let us know how these are generated from the mantle and how it hits the place and causes that to move. It is a big role it plays, but there are some other factors that the forces of tensional forces also work together to tear it apart. The magma that is coming out of this basic lava cones are going to be formed from the release of the basic lava. The magma that is formed there are the basic ones. Describe the nature of conservative plate boundaries. Take this seriously. The rab, okay. So simple question like this, you go and we are unable to answer it. Please don't come to me. Don't come to the office. If you are unable to do it, I will chase you out of the school. You can't really continue the other papers. I'm telling you. I'm giving the word of honor. Because it will never happen. Good. So take note of the descriptions that you can give at the conservative transform margins. At this boundary, the place rub side by side. There's no landforms developing at this place. Friction activity or earthquake is very notorious. Rampant earthquakes. So 3 points for 3 marks. Check the mark allocations, students. I'm not even calling them. You are candidates. Candidates. Don't use the marks allocation to also develop your points. The marks allocation is very, very important there. At the convergent plate boundaries, what is happening there? Convergent plate boundaries. We have been given 2 different boundaries. What boundary is this? What plate boundary is this? Destructive boundaries. This is between what and what? Oceanic plate and oceanic and what? continental. You can go further to give the specific names of the oceanic plates. It's not a matter of going deep. Having gone. This one, they are that reddening is a form of fire, but there's nothing like volcano coming. There's a thrust up. There's a thrust up thrust. Friction, yes, can cause heat. Name the zone Z. The zone Z. Benioff zone is the same as the subducting zone, okay? It's okay. The Benioff zone the same as the subduction zone. Yes. Compare the tectonic landforms and processes, landforms and processes between 3.1 and 3.2. Yes, compare them. If you compare, what are you doing? The differences and the similarities. Yes. Everybody come up with something before we all move. Yes. The main differences in the processes are what? Can you talk aloud for me to hear you, please? It doesn't just go deep. Yes, there is the trust of yes. There's subduction. Yes. Magma giving us these volcanoes. Have you seen a volcano for me? There's no volcano for me here. But there is what? A fold mountain for me here. So oceanic continental. Oceanic continental. You have seen what's happening. Continental, continental. You see it? Do you see continental, continental? Giving us what? So at the convergent plate margins, note the types of landforms and the processes that are going on. If you are asked to draw a cross section of the plate boundary at Z, what will you do? This is okay. Yeah. Then you label it as we have done for the previous ones. You see it? So try to show subduction of the Pacific plates under the Eurasian plates. Let us know the melting of the which one is going to melt? The Pacific or the Philippines, giving us magma, creating volcanoes. Is okay? This is oceanic. How can this be confusing? These are two oceanic. They are subducting. Yes, you have that complex movement. Don't you see that Pacific, Philippine are oceanic, oceanic? Oceanic, oceanic is going to give us what landform is going to be created here? And what? Island arcs. Good. So name the process at Y. Y is what? Are you sure? Y is subtraction here. And doing what? It is doing what? Continental plate. What plate? The Eurasian plate. Good. So the different processes include, so with the aid of examples, assess the role of tectonic processes in determining the type of landforms at different plate boundaries. How do you go by this? The same concept has been repeated and repeated, but the questions, they keep on varying the question by the same concept. Do you get it? What is the direction of the question? What is the direction of the question? So with the aid of examples, assess. So you are evaluating the role of what? Tectonic processes. What are the processes? What are the processes? See first spreading, please. Let's be serious, please. See first spreading, subducting, wetness, conversing, very good, melting, good. All these are tectonic processes. And how do they form these landforms? We have just dealt with the spreading centers. We have also done something on what? Subduction. And you have got to know the type of landforms that are formed here. So you say one and you move on. Yes, subduction. What are the landforms? Go on. So these are the thing are here. That's why they are like that. The questions have been even answered here. So we are drawing from what is on the board there. Okay, so the types of landforms discussed may include ocean ridges, ocean trenches, volcanoes, the volcanic islands, fault mountains, and that of what? Rift valleys. Where do you get rift valleys? Continental. What do you mean continental? If they continental, that's with two continental plates are moving towards each other. I said the interior continents, they what? Tear apart through the fault line, the faulting. Are you taking note and considering the main points? So you have to consider the dominant processes occurring at that particular margin and then use that one to explain your points. Now talking about weathering, you need to talk about the role of the climate, the different types of weathering, as you know, the physical and the chemical weathering. I said that last year they asked questions on physical weathering, but these are the areas that they asked. They were to talk about the types of physical weathering and the processes. Now, those of the chemical weathering processes are waiting for us. So discuss it, revise it well. At this stage, I know that you are conversant with the different types of weathering and the processes that are involved. How freestyle occurs, salt crystal growth, they're all in your notebooks. So take time and revise them. We have done it on the board, so I will not waste time to go there again. But in the case of the chemical weathering process, hydrolysis. I said hydrolysis occurs in what rock? Granite, with mica, feldspar, and what? Quartz, changing to become kaolin. So kaolinization in hydrolysis will give us China clay. The case of carbonation, it occurs from what? It occurs in limestone because limestone contains what? Calcium carbonate. It reacts with weak carbonic acids to give us calcium bicarbonate. That one is the process of carbonation. Hydrolysis. Hydration is what? What about hydration? Anhydride, when water enters anhydride calcium sulfate, okay, it turns them to become hydrated calcium sulfate gypsum. So there's a change of colors. Most of the time, it can change from red to brown, very deep red, the reddening of that. And then the structure, how does the structure of the rock and then the relief of the rock, how does it affect chemical weathering? All these we need to know. Chemical weathering is what we call the deep chemical weathering is what we call the explanation. Explanation. Now look on the diagram here. How is the diagram here helping us understand the concept of basal surface of weathering? And I was asking you to give me the relationship between the precipitation, temperature, and the deep weathering, basal surface of weathering. What do you see from these diagrams? The question is, figure 3.1 shows relationships between precipitation, temperature, and weathering. 1. Describe the depth and location of intensely weathered material shown in figure 3.1. Yes. Describe. Just give me the characteristics. Tell me what it is. I don't know. Okay. What is it right? You're talking to yourself, to your colleagues. Oh, okay. Okay. Let's hurry up and complete it. Otherwise, the depth is shown here. This precipitation. This is the depth. How deep is weathering occurring here? Describe the depth and location of intensely weathered material. This is what? Intensely weathered material, isn't it? Look at the key. Let's move on, please. Are you confronting the question? Well, some of the faces are not showing that we are intensely weathered material. He said, check the rating. Right. Okay. What about B? Describe the relationships between precipitation and weathering zone. Relationship. Describe the relationship between precipitation and weathering shown. The higher the precipitation, the more intense the weathering. Shown by what? Can you give me statistics to support what you are saying? Yes. 2,000 meters. Okay. There is. You said 20 something? Okay, so the higher the precipitation, as you are saying, so there's a positive relationship. The higher the precipitation, the deeper the weathering goes. Okay. What about three? Explain the relationship between. Now, yes, you get it. The first one was what? Describe the relationship. Are you here? The next one is explain what? That's what I'm saying. Read the full length of the question to note the different skills needed in the question. So you say it has a positive relationship. Why do they have that positive relationship? That is the question at C. Sure. Maybe more than that. To the whole class, please. You are now explaining the description. You describe it that the higher the rain, the deeper the weathering. That is the description. Why is that so? The explanation. So question 3C says explain the relationships. We have described the relationships. Now explain the relationship. Tell me why the higher the rains, the deeper the depth. Go on, go on. So what is the, he's talking about what is the role of water in weathering? That's the question. Mm-hmm. To form what? Degradable material. So this question is trying to come out with the rule of rainfall. The first question I gave you on the board, that rainfall is the most important factor in the weathering of rocks. The first question that I raised when I came to class, it is linked to this question. Is it okay? These are the answers to the questions. You were to describe the depth. So, were you correct or wrong? Were you guys correct in your submissions? This is question 1. Here's question 1. This one was a 2. The 3. Yes? 3 was correct? What about 2? It's also having positive relationship. What about the third one? The main point is that precipitation is essential for deep weathering. It's okay? And this needs explanation with regard to specific weathering processes, as we're talking about hydrolysis or carbonation, and the type of rocks that are needed to work on that. So the emphasis in the explanation should be on chemical weathering. So carbonation, hydrolysis. But we can also make mention of physical ones, but that one is on the surface. It doesn't go deep. Are you getting the differences? If we talk on the physical processes are confined to the surface, freestyle. But for chemical, it sinks deep into the bed of it. Have you seen the differences? That's why in an area where you have deep chemical weathering occurring, there is that profuse development of soil because most of the minerals get weathered through chemical processes. It's okay. It's all right? Great. So